Okay, welcome back everyone. So this is the second part of our series of solving the U of H calculus portion of the exam. And yesterday we left off at problem 5, which was this limit problem. And now let's just quickly begin on problem 6. So at each point xy along a differentiable curve, there's a tangent line with slope 2 cosine of x plus 1 over pi. If the curve passes through the point 0, 1, what is the y-coordinate of the curve when x equals pi over 2? Sorry about that. So if we let some function f be that curve that the problem talks about, we're actually given that at every point xy along that curve, that differentiable curve, so we are free to differentiate it, we get a tangent line with the slope of that. That's the definition of a derivative of the curve. So in other words, we get that f prime of x is equal to 2 cosine of x dx, and this is given to us by the problem, this the slope here. Okay, well, let's integrate. And you might be concerned that we get a plus c after the integration, but we can easily solve for that since we're given the initial condition at x equals 0, we get y equals 1. So let's quickly integrate, and we get that f of x is equal to, well, integrating, we get sine of x plus 1 over pi x plus c. So plug in, we get set this equal to 1, then plug in x equals 0. This term goes to 0, since sine of 0 is 0. This term goes to 0. Then we get that c equals 1. Okay. So in other words, we just get that this is going to be, our function is just has a plus 1 at the end here. Okay, and to finish our problem, we simply plug in x equals pi over 2, since the problem is asking for the y value of, in other words, our value for f of x when we plug in x equals pi over 2. So sine of pi over 2 is 1, so we get 2. And then if we plug in pi over 2 here, pi's cancel, and we get 1/2. And then plus 1, of course, and that's 7/2. Okay, so, and, okay, I keep hitting that. Okay, hopefully it focuses. Okay, and actually that's going to be option D, as you can see, hopefully. Okay, so next. Okay. So problem 7 is a bit bulky, but let's try to get through it. The differentiable function capital F of x is given by f of x is equal to the integral from 0 to 1 plus x squared of f of t dt. The line y equals 2x plus 1 plus 7 is tangent to the graph of f at the point -1, f of -1. Based on this information, which of the following statements is true, if any? Or which of the following statements are true? It's not necessarily just one. And I'm not going to read those off. We're just going to try to prove them individually or disprove them individually. Okay, so let's first write out our information, shall we? Okay, so we're given that f of x, capital F of x, is the integral from 0 to x squared plus x plus 1. F of t dt. Okay, and we're also given that, let's see, we're given that at the point -1, f of -1, we get that y equals 2x plus 1 plus 7 is tangent to that. Okay? Well, notice that this means that, what is the tangent line? What is the function for the tangent line to capital F of x? Well, that's exactly going to be capital F prime of x, right? So, because if we add x equals -1, this is tangent, right? This is tangent. In other words, if we take the derivative of this, set it equal, and then plug in x equals -1, this this line here will model, will exactly model that. In other words, we'll get that since, well, if we kind of expand this, we get that that's 2x plus 9. So in other words, this derivative at x equals -1 will have to equal 2, since that's the slope of the line. So using the fundamental theorem of calculus to differentiate this, we get that capital F prime of x is equal to, well, by chain rule, we'll get x squared plus x, f of x squared plus x plus 1 times derivative inside, which is 2x plus 1. Okay, and let's plug in x equals minus 1. And notice that at that point we'll get that, and this is also, we can call this f of x, right? Okay, by the fundamental theorem of calculus. And let's plug in x equals -1, and in that case we'll get that f of -1 is going to be equal to 2. So we can directly set 2 for the place of this. And when we plug in x equals -1 here, let's see, we should just get f of 1, and then we get a -1 here. Okay. Okay, and now, well, we can actually solve for f of 1. So we get that f of 1 is equal to -2. Okay, and actually, coincidentally, this is one of our statements here. F of 1 equals -2. So we've just proved that to be true. Okay, let's look at our first statement, because these are a bit more specific. The area between the graph of y equals f of t and the t-axis along the interval 0 to 1 equals 7. Okay. Well, let's see. So, we need to find, well, let's see. So, what happens when we plug in x equals -1 into here? Well, when x equals -1, this upper bound will become 1, which is the integral we seek, actually. The integral from 0 to 1 of f to t dt. But the problem is we don't know what, well, we actually do know what f of -1 is, but it's kind of masked in disguise, right? But let me show you why. Well, notice this piece of information that we got. It was that this value is, this slope, this line is tangent to this graph at x equals -1 at the point -1, f of -1. Meaning the y value is going to be f of -1. But what is the y value when we plug in x equals -1? It's 7. And that actually just proves this right here. So it proves our statement that this will be 7. So we've got this second and the first statement proved. This third one is the average value of f over the interval 0 to 1 equals 7. So the average value, meaning that it's going to be, what the average value is actually the antiderivative of, so it's going to be, let's see, let me just define this to you. So it's actually going to be the integral from a to b of some f of x dx over b minus a. That's the average value of the function f of x. So let's just apply this here. So we get that the integral of 0 to 1 of f of t dt over 1 minus 0, which is equal to 7 as well. And that's what the third statement says. So in other words, we've just proven all three statements. So that would be option, let's see, B. Okay, good. Next problem. Problem 8. This is a standard problem. So the value of the limit as h goes to 0 of x minus 1 plus h all cubed minus x minus 1 all cubed over h depends on the real number x. The smallest value of this limit occurs when. Okay. Well, hopefully you can notice that this looks very similar to the definition of a derivative of a specific function. What that function is, well, it should be pretty easy to see. So, let's see. So we're given that, okay, the limit as h goes to 0 of this here, so x minus 1 plus h all cubed minus x minus 1 all cubed over h. Okay, well, this looks a lot like the definition of a derivative of some function, like I said. And what happens, so we have a cubed here, and we also have an x minus 1. Let's kind of test out the function f of x equals, well, x minus 1 all cubed. Okay, and let's see. So if we derive this using the definition of a derivative, we'll get, well, the definition of a derivative, if you don't remember, it's actually just going to be, so if we have some function f, it's going to be f of x plus h minus f of x over h. So if we plug that in here, we get exactly this, right? So in other words, this is actually going to be equal to the derivative of f of x. Namely, if we derive this, we're just going to get, well, using power rule, we don't really need to use chain rule here. We get that 3x minus 1 all squared. Okay, and when is this value at its smallest? Well, it seems like, well, it should be pretty clear that this is always greater than or equal to 0. So in other words, it's smallest when it's equal to 0. And the only time it's equal to 0 is when x is equal to 1. And that should be our answer. Yes. So that would be our answer C. So let's go to our probably last problem. And again, I'm going to try to get faster and faster with these. Okay. So let's see. It has a nice graph added to it. So given the graph of y equals f of x in figure 2, it follows that the integral from 0 to 2 of f of x dx minus the integral of from 2 to 4 of f of x dx plus the integral from 4 to 5 of f of x dx is equal to... Okay, so sorry for that cut. I kind of had to... well, my mom came in for a second, so yeah. Anyway, let's continue. Let's see, I kind of lost track. Anyway, so we're given this nice... I'll try to draw it up here. So we're given this nice little graph, and that's this graph here. So, let's see. So anyway, I'll probably, I think I know a easier way to record some of these videos, so that they don't take up as much time. Anyway, 1, 2, 3, 4, should be right, 5. These are all arcs of a circle, to be clear. And what the problem is asking us to find is, first, let's try computing the integral from 0 to 1, to 0 to 2. So that's going to be this half circle with a radius 2. And notice that the area of this, we'll call it A1. A1 is just simply going to be equal to, we can evaluate this geometrically. And that's just going to be 1/2 times pi, right? Because if we take, it has a radius of 1, so we're going to get pi times 1 squared. So that's just going to be pi, which is the area of the full circle, but we're cutting that in half, so we get pi over 2. Okay, and now we want to find the integral from 0 to 4. So this area. So we'll call it A2. And A2 is equal to, well, this is actually a quarter of a circle. It's supposed to look like a quarter. It's supposed to be a quarter of a circle anyway. It doesn't look very good in my drawing, but it's not horrible. And it's actually of radius 2, meaning that it's going to be 1/4 pi times 2 squared, which is going to actually be 2 pi. Actually, it's going to be exactly pi, because, well, we have radius 2, so the full circle is going to be pi 4 pi, right? But we're cutting that into 4, so it's going to be pi. Okay. And finally, this section is probably the most tricky, but it's not that hard. So again, I actually made it look like a rectangle for a reason, because, well, we didn't know how to calculate this on its own. So let's use some complementary area counting. And that we know how to calculate the area of the full rectangle formed here, right? That's just going to be 1 times the total height here, which is actually given. Well, it's not given, it's pretty clear. And the total height there is actually going to be 2. So in other words, the full area of the rectangle is going to be 2. And then we have to subtract from that the area of this arc, or, well, this little 1/4 of a fourth of a circle here, of radius 1. And that's actually going to be exactly half of this, of our A1. So it's going to be pi over 4. Okay, should be correct. Yes, exactly. Okay. And now what the problem is asking us to compute is A1, let's see, A1 minus A2 plus A3, which is this. Okay, well, let's compute that. And let's directly try to collect common denominators. Or maybe not, I'll just try to make it more clear. Pi over 2 plus pi, oh, I should be minus, I already almost messed up. Minus pi plus 2 minus pi over 4. Okay, and this is equal to, well, we have the some 2 on the outside. And then we'll get, well, we'll just get, what is this? This is going to be 2 pi, and then minus 4 pi, minus pi, if I'm not mistaken. So that'll be equals minus 3 pi. So we should get minus 3 pi over 4. Let's see if that's an option. Oh, it is. Okay, it's option A. So 2 minus 3 pi over 4. Okay, and maybe let's just do one more problem. It's actually using the same graph, so it probably makes sense to do that. And let's see. So yeah, it's a fairly straightforward one. So let n denote the number of denote the number of points on the interval 0 to 5 where f fails to be differentiable, and let k denote the number of points in the interval 0 to 5 where f prime of x is equal to 0. So essentially we're looking at critical points. And then we want to calculate 2 to the 2021 to the n minus k. Well, I'm not going to clear the graph yet. So when does it fail to be differentiable? It fails to be differentiable here, 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 here. So well, these two are sharp points. That's why they fail to be differentiable. And however, these two, the limit doesn't exist on both sides. So in other words, that's why they're not differentiable. Now the limit, the points where f prime of x equals f prime of 0 is equal, f prime of x is equal to 0, well, looks like we have it here, and that's the only place, because we can't do it. The only other possibility might be here or here, but those points both are not actually, well, differentiable, so we can't use those. In other words, our final answer should just be, well, we should have 4 minus 1, which is going to be 2021 cubed. However, well, let me just check if we got the order right or wrong. So let n denote the number. Yeah, so it should just be 2021 cubed. However, it's not there. In other words, the answer would be none of the other answers provided. So that would be option E, as usual. Okay, well, hopefully you enjoyed that video. There are many more parts to come, and just notify me if you are enjoying the series. Anyway, have a nice day, and goodbye.